Welcome to this explainer. Okay, today we are breaking down a seriously ingenious step-by-step solution to what is arguably one of the absolute most frustrating math hurdles for kids, division with remainders. And to kick things off, let's picture a short animated sequence to really identify the core problem right out of the gate. So, in this animation, imagine a young student happily strolling along a math path. They're easily jumping over addition, hopping over subtraction, but then, bam! They slam into a massive brick wall. That wall is division. Let's ask a really fundamental question here. Why do so many young learners hit this massive barrier? What is it about this specific operation that just completely spikes their anxiety?
Well, the core of the problem really comes down to traditional teaching methods, which lean super heavily on boring, repetitive, rote memorization. It's just drill after drill. And honestly, this approach completely fails to build a true hands-on conceptual understanding of what equal distribution actually is. When students are just forced to memorize times tables without ever seeing how those numbers are physically shared, the whole concept just stays totally abstract and confusing.
But wait, the absolute ultimate villain, causing all this anxiety in the mathematical struggle, it is, without a doubt, the remainder. Whole numbers are one thing, right? But the very second a student has something left over that doesn't fit neatly into a group, total panic sets in. To them, it literally breaks the clean math rules they've spent so much time memorizing.
Think about this brilliant quote directly from our source material. Without a concrete way to visualize these leftover quantities, pupils are unable to solve division questions independently. This hits the nail on the head, and it's exactly why this matters so much to us. Because when students lose their confidence here, it builds an immediate, massive roadblock to mastering advanced math later on, like fractions and percentages.
Introducing the Bijak Bahagi module.
Okay, so here is the solution. It was developed by an awesome team at University Utara, Malaysia through their Sulam project. And it brilliantly bridges the gap between those abstract concepts and actual concrete understanding. Their operating theme is so good. Hands-on division, minds-on learning. Instead of just zoning out staring at a whiteboard, students are handed a tactile, game-based intervention that physically transforms how they interact with numbers.
A few moments later.
Measuring the impact. Now, you might be wondering, did this actually work? Well, to measure the real-world success, the university students behind this project didn't just guess. They implemented a highly structured pre-test and post-test questionnaire. The shift in focus here is amazing. The pre-test measured things like boredom and perceived skill weakness, while the post-test measured excitement and comprehensive understanding. The data effectively tracked exactly how this module shifted pupils from finding math incredibly boring to actively enjoying and really mastering the subject.
It's also super important to highlight that this isn't just basic arithmetic. This module is kind of like a Trojan horse for deep STEM principles. It naturally incorporates science through algorithmic logic, engineering through the physical structural manipulation of the 3D printed tray, and of course mathematics through the core principles of sharing. It's a remarkably comprehensive educational tool.
The future of learning.
And the creators are already looking ahead to where this goes next. They're envisioning scaling this physical prototype into a digital app for hybrid learning environments. They're even looking at integrating QR codes for instant video hints. But actually, the most exciting part is topic expansion. They want to adapt these exact physical compartments to teach even more complex topics. Just imagine using this same tray to visually demonstrate part-to-whole relationships for fractions, or modeling ratios and decimals.
Which leaves us with this final, really provocative thought to take away from this explainer. If manipulating a few plastic tokens in a color-coded tray can completely cure division anxiety for primary schoolers, what other massive academic walls could we break down with the right tactile game? Thank you so much for exploring the Bijak Bahagi solution with me today. Keep asking questions and keep learning.
I just had to let you know you're